What is up, everyone, and welcome back to another video. First of all, before we even begin this lesson, please make sure that you watch that link that I posted prior to this video beginning. It is Felix Baumgartner. He holds the record for the longest base jump known to man, as well as pretty much the fastest free fall that he's ever gone. So if you haven't watched it, I recommend you do that, but it goes over some pretty crazy stats. Like he broke this, well, he didn't break it, but he traveled faster than the speed of sound in his free fall. So if you want to read a little bit more about it, I suggest that you do because it's a pretty cool story. But this is a kind of fun introduction into one-dimensional kinematics. And so we're going to be seeing this example of Felix Baumgartner as with his space jump, pretty reoccurring in this unit. But other than that, welcome. Thank you for joining in. And what I want to do is I want to kind of get started on one-dimensional kinematics. So without further ado, I will kind of continue. So what is one-dimensional kinematics? One-dimensional kinematics, or well, one dimension is only moving from left to right or up to down. Kinematics is just simply the study of motion. Okay, so I'll kind of go a bit more into, there is 2 and 3D kinematics, but we're just going to focus on only the one dimension. But kinematics, once again, is just the study of motion. This is going to be a pretty foundational building block in your study into physics, as well as you'll kind of see these terms pretty reoccurring. But we want to kind of talk a bit more about these common measurements of position, velocity, and acceleration. So today I'm going to be mostly focusing on position and velocity, but acceleration I'll be kind of introducing into another time just because it is a little bit more conceptually harder to understand if you don't understand what position and velocity are. So with that, let me go talk a little bit more about this. These measurements are typically measured in the metric system of meters, meters per second, and meters per second per second. So please know that that's going to be the units typically measured in this section. But yeah, I'll kind of continue forward into what displacement is. Okay, so, well, position and displacement. So let's kind of talk about this. So what is position? So positioning is going to be pretty much the distance, or at least where an object is kind of oriented from a specific frame of reference. Okay, so for example, in this case, we have down here a house and a park, and we have a lady walking. Okay, I'll get to the lady walking in a second. But position is going to be the actual area where that person or where that object is going to be located. So in this case, I'm orienting my house to be 0 kilometers, and the park is going to be oriented as 5 kilometers. Okay, so let's say I want to determine at what position is my park in reference to the house. And so this could be kind of a way of saying a distance, but you'll hear me say positioning a lot more. Okay. So now with that understanding of what position is, let's go over displacement. Displacement is going to be the change in position of an object from a certain frame of reference. So in this case, let's say here is my lady. She starts at her house and she wants to go to a park. So her change in position is going to be calculated. Here's the math part of it, is going to be calculated from her final position where she ends up minus her initial position. So in this case, displacement is just going to be how far did that person travel in that case. So here, the lady walked from her house to the park. Her final position is the park, which is at 5 kilometers. Her initial position is at the house, which is at 0 kilometers. So her total displacement was 5 kilometers. All right. So now, tricky thing is this. Displacement can also be, since displacement is a vector, that means it is going to be dependent on direction. So therefore, if I switch this and said, okay, the lady walked back from the park and to her house, her displacement, her final position is going to be her house, which was at the 0 kilometer mark. and her initial position was going to be the 5 kilometers. So her total displacement is going to be negative 5 kilometers. Okay, so displacement is just going to be your final position minus your initial position. Okay, so hopefully you guys have a good understanding of this, and know that this is going to be a vector. The following terms are going to be vectors, and pretty much from now on, we're going to be talking about vectors. So with that, I'm going to move on to velocity. So now velocity, once again, I did kind of mention this a little bit more into my vectors and scalars video. So if you didn't understand it that well of what a vector is, please watch that video. But I did review a bit more about what velocity is. And velocity is just the speed of an object, but it also deals a bit with direction. Okay, so in this case, we know velocity is a vector. It's just kind of like you look at a speed limit sign and you say it's a 60 miles per hour, or you can't go over 60 miles per hour, which is how fast something is going. But then you also have to include a direction saying north in some case. Okay, so hopefully you guys understand velocity. But what I want to do is I want to introduce this simulation. Okay, it's called the Moving Man. And you guys are probably going to be using this simulation pretty, or kind of a lot-ish in this section, so that way you guys can understand kinematics a little bit more along graphing it, as well as kind of understanding mathematically how can we determine the velocity of an object and whatnot. So before we even get into this, let me even show you a little basic features. Actually, let me hit reset all really quick. Boom, boom, boom. Okay, so let's talk about position. So here is going to be my orientation. Let's say I wanted to start at the tree. So my position I start off is going to be -8 because I could see it says -8 on the bottom. And then let's say I wanted to move 2 meters per second. And let's not talk about acceleration just yet. So as I hit play, I could see that my time is going to be moving. I could see that my position is going to be changing. And let's see how far he gets when 5 seconds hits. And oh, there we go. I'll stop it there. It's pretty close to 5, but he is going to be at 2 meters in this case. All right, so he started at 8, -8, and he moved to 2. So you guys can kind of play around with this whenever you guys have the opportunity to. But in your next assignment, you're actually going to be not really doing a lot of calculation, but a little bit more about position versus time graphs, or more about position versus time graphs. Okay, so what I want to do is, first of all, let's say I want to give him like I want to move the moving man, and I'm going to click and hold him to this position right here. So notice that my graph is moving. So in this case, as time goes on, we could see that, actually, let me move him to 5 so that way you guys can see that a little bit better. There we go. So I'm going to move him to 5. Okay. So as you can see at my position, he's positioned at 5. And as time increases, we could see that it's just going to be kind of a straight line, right? So now let's see what happens. Okay, so I'm going to move him all the way over here. Don't mind that. But you're going to kind of see this type of motion on the graph, and you guys are going to have the opportunity to play around with this and understand a little bit more on how these graphs work. But let's say I wanted to give him a velocity of 2, and then I want him to start walking, and then you'll notice a form of a change in this graph. So in your next assignment, you're actually going to be using this walking man simulation, and you're going to be kind of using this to kind of determine what these position versus time graphs will kind of look like. Okay, and then later on, when I give you the opportunity to, I'm going to give him 0. Okay. When I give you, let's say I give you this type of graph, and I say explain to me what the walking man is doing in this particular graph. You're going to explain exactly what is happening according to his motion. But other than that, thank you so much for joining in. I hope you learned something with me today, and I will see everybody tomorrow.